Welcome to Guru Brahma classes for JEE and NEET. We are in the chapter Chemical Equilibrium. In this session, we are going to discuss about the relation between Kp and Kc. Okay, in the relation between Kp and Kc, we are solving PYQ of JEE main. PYQ of a JEE main. So let us see. So these are all the questions on the relation between Kp and Kc, right? What is Kc? Kc, it is equilibrium constant. We can say equilibrium constant. Kp and Kc both are equilibrium constant. Okay, Kc, C here represents the concentration of the reactants and products. So we can write a equilibrium constant with respect to concentration. With respect to concentration. So whose concentration? Concentration of reactant and concentration of products. And what is Kp? That is also equilibrium constant. This is also equilibrium constant. With respect to pressure. With respect to pressure of reactants and pressure of the products. So when do we measure pressure? When the reactant or product is in a gaseous form, then we take pressure of that gas into the consideration. So here Kp means equilibrium constant with respect to pressure. Kc means equilibrium constant with respect to concentration. Right? And what is the relation between Kp and Kc? Already we have derived that Kp is equal to Kc into RT power delta N. RT power delta N. Where what is meant by delta N? Delta N is equal to Np minus Nr. So what is Np? What is Np? So Np is equal to number of moles of gaseous products. Only products which are in gaseous states. Number of moles of gaseous products. Nr is equal to total number of moles of gaseous reactants. Gaseous reactants. So that is what, so this delta N, and Np means total number of moles of gaseous products, and Nr means total number of moles of gaseous reactants. Okay, the difference in the number of moles of gaseous products and number of moles of gaseous reactants gives you delta N. Okay, and what is R? R is universal gas constant. Gas constant. And you know capital T is absolute temperature. Absolute temperature. Okay. So these are the meanings of that formula which we have already derived. What is that formula? Kp is equal to Kc into RT power delta N. Okay. So based on this formula, very frequently questions are being asked in different competitive examinations. In this session, we are speaking about the questions which are asked in JEE main. So here the question asked in 2014. What is that question? Let us see. SO2 in gaseous state. SO2 is reacting with half O2 in gaseous state, giving you SO3. What will be delta N? We know that delta N is equal to, for this question, okay, let us write here. So delta N is equal to Np minus Nr. So if you see the product is sulfur triaxide, there is only 1 mole. Number of moles 1 minus. Okay. In the reactant side, there is 1 mole of sulfur dioxide and half mole of oxygen. So add them 1 plus 1 by 2. That is equal to how much do you get? 1 minus 1 minus. Okay. So 3 by 2. 1 minus 3 by 2. Then what do you get? So 2 minus 3 by 2, that is equal to minus 1 by 2. Minus 1 by 2, right? So here they are asking Kp is equal to Kc into RT power x. What is this x? Now x is equal to delta N. Delta N we have calculated it as minus 1 by 2. So the answer will be minus 1 by 2. So option will be second option, right? Next question. Let us see. So the value of Kp and Kc for the following reactions at 300 Kelvin are respectively. So at 300 Kelvin, the product of R and T is given as 24.62 decimeter cube atmosphere per mole, right? So let us take this as first equation. So our A, B, C, 2, 3, let us take. These are the options given. And for these three reactions, the relation between Kp and Kc is asked. Okay. So that's the thing. Now let us see. First reaction. So if you see first reaction. So what is that first reaction given? N2 gas plus O2 gas gives you 2NO gas. What will be delta N? Delta N is equal to Np minus Nr. That is equal to, so all these three are in gaseous form. Products, how many moles are there? 2 minus, okay, number of moles of gaseous reactants, both nitrogen and oxygen are in gaseous state, 1 plus 1, so 2, then that is equal to 0. Okay, then Kp is equal to Kc into RT power delta N. So that is equal to, okay, so then what you write? That is equal to Kc into RT power 0. Anything power 0 here in this context is equal to 1. So Kp is equal to Kc. Okay. For first reaction, Kp is equal to Kc. And what is asked? The value of Kp by Kc. So for the first reaction, Kp by Kc will be equal to 1. Right? So 1, how many options you are finding? 1, 2 and 4. Okay. So 1. So you cannot go with the third option. Okay. Next, coming to second reaction. Let us see second reaction. Second reaction. The second reaction, what is given? N2O4 gaseous is converted into 2NO2 gaseous, right? What is delta N here? Delta N is equal to Np minus Nr, that is equal to 2 minus 1, that is equal to 1. Okay, delta N is equal to 1. When delta N is equal to 1, then we know that Kp is equal to Kc into RT power 1. Okay. So what is the question? Kp by Kc is asked. So Kp by Kc is equal to RT. Already RT, what is the value of RT already given? Right? 24.62. So you will get 24.62, right? Decimeter cube atmosphere per mole. Right? So where is that? 24.62 and 24.62. First and fourth option you are finding for the second equation. Next, let us go with the third equation. For the third equation, what is given? N2 plus 3H2 gives rise to 2NH3 and all are gases. All are gases. Then what will be delta N? Delta N is equal to Np minus Nr, that is equal to products 2 minus 1 plus 3. So 1 plus 3, 4, that is equal to minus 2. Okay. So then delta N we got. Then we have to calculate Kp by Kc. We know that Kp by Kc is equal to RT power minus 2. Okay. RT power minus 2. Then if you calculate RT value already given, 24.62 decimeter cube atmosphere per mole. Okay, this is already mentioned. Power minus 2, that means root, not root. Okay, squaring. So you are getting 1 by 24.62 whole square decimeter cube atmosphere per mole whole square. Okay. So minus, as there is minus, when it comes to denominator, it becomes a plus. Okay. On solving this, what do you get? So Kp by Kc will be equal to 1.65 decimeter cube square, and it is in the denominator. Then what do you get? Decimeter cube decimeter power minus 6 atmosphere. In denominator it is there. When it comes to numerator, atmosphere, okay, minus 2, right? Per mole it is there, and square it you are having. Then what do you get? Mole square. Okay, so 1.65 decimeter power minus 6 atmosphere power minus 2 mole square. So where do you find the answer? You are finding the answer, and you will have the answer 1.65 into 1.65 into 10 power minus 3. Here you see 10 power minus 3, because 1 by 24.62 whole square, 1 by 24.62 whole square gives you this value, 1.65 into 10 power minus 3. Okay. So the answer will be the fourth option. Okay. So let us go with the next question. So in which one of the following equilibria Kp is not equal to Kc? Okay. If delta n is equal, already we have seen, if delta n is equal to 0, we have studied that Kp is equal to Kc. Okay. If delta n is not equal to 0, then what happens? Automatically Kp will not be equal to Kc. Okay. So let us find in which options we are having delta n is not equal to 0. So first reaction, let us take what is delta n? Delta n is equal to Np minus Nr. How many moles are there? 1, 1, 1, 1. So 1 plus 1, 2. 2 minus reactants also 2, that is equal to 0. So here for first option Kp is equal to Kc. Second one, let us take delta n is equal to, how many are there? Right side 1, 1, 1 plus 1, 2, 2 minus On the reactant side also 2, so that is equal to 0. Here also Kp is equal to Kc. Third option you see delta N 1 1, so 2 minus 2, that is equal to, all are gases, only here you can find it as solid, right? So for the third option also Kp is equal to Kc. For the fourth option, if you see delta N is equal to 2 moles on the right side, left side only 1 mole, because this is solid. Carbon is solid, whereas oxygen is in gaseous form. So 2 minus 1, that is equal to 1. Here delta N is not equal to 0. When delta N is not equal to 0, automatically Kp is not equal to Kc. And we have studied that Kp is equal to Kc into RT power delta N. Here delta N is 1. Okay. Then Kp is equal to Kc into RT. R value we know, T value you know, that is greater than 1. It will be always greater than 1. If it is always greater than 1, automatically Kp is equal to Kc into number which is greater than 1. RT will be always greater than, okay, 1. Right? So when RT is found to be greater than 1, or then automatically in this condition, in this condition, what you can write, see R value, if you take R value, we know that it is 8 point R value. R is equal to different R values. If you take 0.0821 liter into atmosphere per mole per Kelvin, or if you take R is equal to 8.314 joule per mole per Kelvin. So whatever the values you take, R into T, generally it will be greater, and Kp will be always greater than Kc here. Okay. And another condition, let us see, if delta N is, here delta N is greater than 0. The condition here greater than 1 is greater than 0, right? Delta N is less than 0. That means delta N is negative. If it is negative, then what happens? Kp is equal to Kc into RT power minus. So then Kp is equal to Kc by RT. For example, let us take minus 1. So Kc is equal to Kp into RT. Then what happens? Automatically Kc will be greater than Kp. Kc will be greater than Kp. So what we need to understand is, if delta N is equal to 0, Kp is equal to Kc. If delta N is not equal to 0, Kp is not equal to Kc. And if delta N is greater than 0, then Kp will be greater than Kc. And if delta N is less than 0, then Kc will be greater than Kp. Okay, so these are the conditions which we need to remember. So here answer will be what? Fourth option, right? Because delta N is not equal to 0. Very simple question is here. So let us see. Again, what he has asked us the relation between Kc and Kp. So first of all, let us calculate delta N for this reaction. Delta N is equal to Np minus Nr, that is equal to, this is solid. Which one is solid? Iron is solid. Here Fe2N is also solid. So we don't consider them, because in the formula Np minus Nr, this Np is number of moles of gaseous products and Nr is number of moles of gaseous reactants. So when there is solid and when there is solution or liquid, we don't consider them, right? So NP number of moles of gaseous products 1 minus number of moles of gaseous reactants is 3 by 2, that is equal to, so 2 minus 3 by 2, that is equal to minus 1 by 2. So we have delta n is equal to minus 1 by 2, then Kp is equal to Kc into RT power minus 1 by 2. Okay, then Kp is equal to Kc by RT power 1 by 2. Because it is minus, when it comes to denominator, automatically it will become plus. Then I can write Kc is equal to Kp into RT power 1 by 2. So Kc is equal to Kp into RT power 1 by 2. RT power 1 by 2. Okay, so where do we have this option? So Kc is equal to Kp into RT. So wrong. Kc is equal to Kp into RT 3 by 2. No. Kc is equal to Kp into RT power 1 by 2. So this we got. So third one. Kc is equal to Kp into RT minus 1 by 2. So wrong. Okay. So let's see the next question. Asked in 2024. Simple question. How do we solve this? We know that Kp by Kc is equal to RT power delta n. So the reaction given, what is delta n? Let us calculate. Carbon dioxide 1 mole minus of carbon monoxide, all are in gaseous state, right? So 1 plus 1 by 2, that is equal to 1 minus 3 by 2, that is equal to 2 minus 3 by 2, that is equal to minus 1 by 2. So we have delta n. Delta n is equal to minus 1 by 2. So then I can write Kp by Kc is equal to RT power minus 1 by 2. That is equal to 1 by RT power 1 by 2. That I can write it as 1 by root RT. Power 1 by 2 means root RT. Okay. So where do we have that option? We have that option in, right? Here you see third option. Are you finding? Yes. So such simple questions can also be asked in the examinations. So this is asked in 2021 and a numerical value type question. Consider the reaction N2O4 gives rise to 2NO2. The temperature at which Kc, we have Kc and Kp, and we are asked about the temperature. What is asked? Temperature is asked. Okay, and we know that the formula Kp is equal to Kc into RT power delta n. What is delta n for this reaction? Delta n is equal to 2 minus, here we have 1. Both are gases, right? So 2 minus 1, that is equal to 1. So Kp is equal to Kc into RT power 1. Okay. So then that is equal to Kp is equal to Kc into RT. And we have to calculate what? T, temperature. So temperature is equal to, what is asked? Temperature is asked. Temperature is equal to Kp by Kc into R. Kp value given as, see how much? 600.1 by Kc. Kc is given as 20.4. 20.4 into R value 0.0831. Okay. So if you calculate this, what answer do we get is 354. What is that? 354. So 354 Kelvin. At 354 Kelvin, okay, these will be the Kc and the Kp, right? Simple question. What is just absolute temperature? They have given us Kc and Kp. So this take time for calculation. We should be able to do calculation. We should practice more division, multiplication. Then we can get the accurate answer for numerical value question. Here they are not only testing us our knowledge on the formula, they are also testing our calculation power, especially numerical value questions. If the question is asked from physical chemistry, you will be not only tested about the concepts definition, but you are also tested regarding this calculation, how accurate, how fast, how proper your calculation is. Okay, you should practice those calculations. So the answer is what? 354 Kelvin. Next question. Again, we are solving questions, numerical value questions. The value of Kp is given. How much? 47.9. For the reaction N2O4 gives rise to 2NO2. Kc is asked for this reaction at the same temperature. Okay, you know the formula. Kp is equal to Kc into RT power delta N. What is delta N here? For the reaction, for the given reaction, what is delta N? 2 minus 1. Both are gases, right? So 2 minus 1, that is equal to 1. Then what I can write? Kp is equal to Kc into RT. Okay. So what is given? Kp given, Kc is asked. So Kc is equal to Kp by RT. That is equal to Kp how much given? 47.9. R value how much given? 0.083 into temperature is how much given? 288 Kelvin. 288 Kelvin. So on calculating this, what do you get the answer? 2. What will be the answer? 2. Okay. Simple, very simple question is again given, asked in 2021. Here the question asked is in 2024. So what is that question? Again, from this reaction we can say that delta N is equal to here 2, 1. So 2 minus 1, that is equal to 1. Kp given. Okay. Kc asked. We know that Kp is equal to Kc into RT power delta N. So Kp is equal to Kc into RT power 1. We need to calculate Kc. Kc is equal to Kp by RT. Okay. So then that will be equal to Kp given how much? 0.492 atmospheres. Okay. And Kc asked R value 0.082. Up to only 2 is gave us liter into atmosphere per mole per Kelvin into R value or K value. K, what is the temperature at which this reaction is occurring? 300 Kelvin. So on substituting this, what do you get? Let us see. I can write this as 492 into 10 power minus 2 by 82 into 3. Okay. So 492 into 10 power minus 2 by 3 to 6, 8 3 is 24. So 246, 492, 46 to 92. So then what do you get? 2 into 10 power minus 2. So the answer will be 2, because the question is asked is in into 10 power minus 2. So the answer will be 2 into 10 power minus 2. Okay. Next question. Asked in 2023. What is the question? For the reaction SO2 plus half O2 gives rise to SO3. Kp is 2 into 10 power minus 12 at 27 degrees centigrade and 1 atmospheric pressure. The Kc for the same reaction is the same similar type of question. So in this session, we are solving questions, that is P by Q, on the relation between Kp and Kc, exclusively asked. So similar type of questions. So what is that? Delta n. Let us calculate for delta n first of all. Delta n is equal to, see, 1 SO3, 1 minus 1 plus 1 by 2. That is equal to 1 minus 3 by 2. That is equal to 2 minus 3 by 2. That is equal to minus 1 by 2. So we have calculated delta n. Then we know that Kp is equal to Kc into RT power delta n. That is equal to Kc into RT power 1. Kp is equal to. So what is asked Kc? Kc is equal to Kp by RT. Okay, here it is minus 1 by 2. How much? Minus 1 by 2. RT power 1 by 2. Okay. Then what do you get? Delta n, what did we calculate? Minus 1 by 2. That minus 1 by 2 we have substituted here. So Kc is equal to Kp by RT power 1 by 2. So Kp by, what is the Kp given to us? Kp given is 2 into 10 power 12 by R value 0.082 into temperature 27 degrees centigrade. 27 degrees centigrade is equal to 273 plus 27, that is equal to 300 Kelvin. So 300 whole power 1 by 2. So on calculating this, what do you get? You get 1 into 10 power 13. On calculating this, we get what value? 1 into 10 power 13. So the answer will be 1. Okay. So that is how the questions are asked in in JEE Mains. We have solved all the PYQ from JEE Main regarding the relation between Kp and Kc. So that is all with this session. In the next session, we shall discuss the other topic. Thank you for watching. Let us meet